Welcome friends, in this section we will go through the schematic drawing in detail. So basically this is the schematic drawing for star data starter, and you will find this drawing in each drawing which is provided by supplier. So the concept will remain same. The name of some contactors can be changed or some symbols can be changed, but the basic concept will remain the same. So we'll start with the naming. S0 is basically the off push button. This is S0. If you want to switch off, you have to press this, and this is kind of push button. When you push it, it will come back to its position. Then we have S1. This is S1, and S1 is basically the on push button. So if you want to switch it on, you just have to press it and it will come back to its, after just touch, it will come back to the position, normal position, and the motor will be started. Then we have K1, which is a line contactor. This is K1 here, and you can see the auxiliary contact of K1 are here, which are directly in series with the motor winding. Then we have K3, and then we have K2, which is called a stator contactor, and this is basically K2, which is used to make the relay in star. This is actually star contactor. Then we have K3, which is a delta contactor. This is K3, and this is the auxiliary contact of K3. So we will see how it is working. Then we have K4. This is a K4. This basically just look like symbol, like a contactor symbol, but the cross is put it here, then it's making a contactor with a timer. So it's basically a timer relay, K4. Then we have F2, which is overload relay. This is F2, thermal overload relay, which is connected in series with the motor winding. If basically motor is overloaded or heated up, this MCB will cut off the supply of the motor. Then we have F1. F1 is basically the backup switch. It's installed here. So if there is a short circuit anywhere, this switch will fuse will blown up, and it will save the motor from any damage. And this is basically the diagram. So let's start now how it's working. So here you can see this is basically this section. A is basically the power circuit, where the power supply is coming to the motor and it's going back to make a delta or to make a star. This portion is basically power circuit and this portion B, it will be called as a control circuit. So we have two circuits, power circuits and control circuits. So here you can see the three-phase power is available here, L1, L2 and L3. Three-phase power is available, and through fuse it is coming to the contactor auxiliary contact and then after auxiliary contact it's going to the thermal overload relay, and then thermal overload relay is going to the motor. So normally when K1 is not energized, this position of contact is now of K1 is open, and K1 will be open if K1 auxiliary contact will be open, like this one, which is called as normally open contact. If the K1 contactor is not energized, so those contacts which are following the status of contactor, means if contactor is de-energized, this contact is open. When the contactor is energized, this contact is closed. These are called normally open contact. So this is the normally open contact of K1, this is the normally open contact of K3, and this is the normally open contact of K2 contactor. It means if I give supply to K1, then this K1 will picked up, contactor will picked up, and this contact status will change from open to closed. And because we change the status of contactor K1 from de-energized to energized, the status of this contact will change from open to close. So this is basically some concept. So if for example now we will see, and this is the contactor K3. If you want to energize the motor, this contactor has to pick up, and if you want to connect the motor in start, you can say K2 should be picked up, Now because this winding is connected, if the K2 is picked up as energized, then the windings are connected in star, and if after some time when the motor is at full speed, the K3 contactor will K2 will open and K3 will be connected, and then you can see the windings will be connected in delta. So this is basically the concept. We will now come to the control circuit. So here you can see they have installed two fuses, F3 and F1 here. These are the fuses, and then this is the contact of F2. Okay, and then you can see here, this is basically the push button to switch it off. We will assume that the motor is already off and you want to make it on. So normally all the drawings which are shown in any drawing, all the symbols and the status of contactors and breaker isolator, they are isolator and breakers are shown in open condition, and the contactor are shown in de-energized positions. So if you want to like to study more about the drawings, I have a lot of lectures about the drawing. If you want to start from scratch, then you can start with my lectures of introduction to drawing 1 and 2. And if you have some knowledge, then you can directly go to the some drawings package that I have, like drawing of line protection, bus bar protection, overcurrent, medium voltage, AC/dB, DC/dB. There are a lot of drawings available, but this package will be a little bit faster. So if you want to make your base, then you have to go to my basic courses. So now if the supply, for example, supply is available here, control supply is available here, which is basically DC supply. The power supply here is basically a 3-phase AC supply. So positive DC is available here at this point, and if you want to switch it on the motor, we will press the button S1. The S1 will be, let me open the paint. So if you want to if you want to start the motor, you have to press this. Okay, so you have to then push this. When you push this S1, then S1 is now connected because you have pressed it. So DC supply which was available up to this point here, because for example now DC is let's take the DC is coming from here to here. When once you press it, the DC supply further coming down to this timer. Okay, supply is coming here, and then another supply that is going to another loop is, because this is open, supply will not come here, then it's going to, okay, K1 and K2, and okay, so this, when this one is picked up, okay, so when the K4 is picked up here, then it has two contact. One is contact that is operate without delay, and this contact here, you can see this contact will operate after delay. For example, if you set the timer delay here 2 seconds, this contact will operate. This is the contact of a K4 auxiliary contact. So this is its contact. So as soon as you press this one, the voltage will come here up to the timer K4. This contact is instantaneous contact. So as soon as K4 is energized, this will picked up and this will be close. So when K4 is close, here you can say K3 is already de-energized, so this is normal close contact. So normal close contact is that contact which will be closed if the relay is de-energized. So that DC supply will come and energize the contact K2. So once the K2 is energized, this contact will picked up, because this is the auxiliary contact of this K2 relay. So how auxiliary contact is working, for example, I will just explain again. If this is a contactor K2, for example, this is a contactor K2, it has two contact. One is normally open contact, another one is normally closed contact. So when there is no supply, the normally open contact will be open, and normally closed, we are calling it as NO, and normally closed contact will be closed, we are calling it NC. So normal position of the contactor is de-energized position. So as soon as supply is provided, so we give positive and we also give negative, this contactor will picked up, and when it picked up, this contact status will change from open to close. Then this will be now closed, and this will be from close to open. So NC will become open. So this is how basically the contactor is working. So here you can see that now this contact when K2 picked up, this contact will be closed because it's from the open contact, and then DC which was coming here through this contact, it will energize contactor K1. So now K1 is energized. When K1 is energized, it will operate its auxiliary contact K1, which is a normally open contact. This is the auxiliary contact of K1. So this will picked up and this contact will close. Now this will happen almost in with the fraction of second. So you will see. So now if the person release the switch, the contact K1 is will remain closed because the K1 will remain picked up through its own contact. This is another K1 contact, these two contact. Basically the contact which is keep on energizing the contactor even after that the push button is released is called salient contact. Now because even this push button is released, because this contact was picked up, K1 was energized, so this contact is closed, this is closed. Now the contactor K1 will keep on energizing itself through its own contact, and these contacts we are calling it in our protection engineering terminology as a seal-in contact. So this is a seal-in. Now the status of this contactor is sealed. So now this is picked up. So what will happen now? This K1 is picked up, this K1 is picked up, and this K1 is energized. And you can see when the K1 is picked up, it's not only giving power to the K1 positive supply as a salient contact, but the DC is also going from here to here and then here, and then it's giving supply to K4. So timer is continuously on. For example, if we preset the time, we know that the motor will come to its rated 90% or 100% speed within 5 seconds, for example, or 2 seconds, as provided by manufacturer, within a second, for example. Then this timer we have to set it as per the requirement. So if we set the timer just before the motor is reaching to its maximum speed, it will not be beneficial, and it will what will happen, that motor is not reaching maximum speed, and if we connect again the motor to delta again, it will be the same thing, that it will be huge inrush current. So there is no use of the star delta connections if the timer setting is wrong. Now okay, when the timer is picked up, for example 1 second time, when it's picked up, what will happen? When the timer is picked up, it will open this, it will close this contact K2. So when K2 contact will close, you can see when the K2 contact is closed, you can see this K3 will picked up. So now the contactor is energized, so it means it will first it will again, then this contact will back to 0 because now contactor is picked up, and this contact will close after preset point time delay of 1 second. The status of this contact will become off, and this contact of the timer will become closed. So it means that the K2 is now de-energized, so this contact is open, and if the K2 is de-energized, this contact is closed because it's normally closed contact, and then K3 is picked up through this. So you can see the supply is coming here from this contact. Now this contact is closed. K2 is already, because this contact is open, K2 is already de-energized. So now the K3 is picked up, and when K3 is picked up, this is the auxiliary contact. This contact will close. Okay, this will be closed, and motor will be connected in delta, and you can see this contact K2 will open, so the star connection will become open. So this is how basically the relay is working. So this basically, let me show you little bit again. Here you can see when the star connection is connected, the motor windings are connected in star, but when after preset time delay, the star will become open and the delta will be connected. So you can see this delta will make all necessary arrangements. It will connect the star winding of red phase to basically the yellow phase, and it will make a delta windings. So I hope that you understand the logic. At the end I will again briefly explain the things. So if you want to switch on the relay on the motor, you have to press S1. When S1 is pressed, the timer K4 picked up and it will close K4 immediately, and this timer will close after preset time delay. So when K4 is picked up, K2 will energize, which is basically K2 is star contactor. So you can see the K2 is energized. So when K2 is energized, then you can see the motor windings. K3 is now de-energized and K2 is energized, so motor windings are connected in star. So it means this contact is closed and motor is now have some connection. And then when this is energized, when K2 is energized, you can see here this contact will close and supply will be available from this point through K2 to K1. When K1 will pick up, the contact of K1 will close. So this is closed, this is closed. Now the supply, even if K2 is even de-energized, the supply will be through from K1 on contact, and it will be kind of this supply is coming to, and now K1 will keep on energized through its own contact, which are calling a salient contact. So now if for example, now if you want to switch it off, now the supply at the moment is feeding. Okay, after this is the case 1 and case 2. When this contactor picked up, okay, at the moment supply is going like this through this one. K2 is also picked up and this is also picked up, the timer. This is closed, and when the timer completes time, the time delay contact will close. It means the K3 will energize, and when the K3 will energize, it will disconnect the K2 timer. So the K2 contactor will be disconnected here. There will be a disconnection here. So the K2 will be de-energized and the motor start point is now open, and then K3 is energized now. So when K3 is energized, the motor is connected in star. So now motor is connected in delta. So now at the present, now the motor is connected in delta, and this K2 here, this contact will also be switched off, and there is a continuous connection. Now if you want to switch the motor off, we will press S0. When we press the S0, so we will push it. When push it, the supply here will be 0. So when the supply here is 0, when you disconnect the supply here, all the contactors will reset and will come to this normal position, and the relay will be switched off. So this was some theory, and it's very simple and basic to understand. So I hope you enjoy my lecture. We'll go to the next lecture now. Thank you very much.